Okay, so just to quickly introduce myself, so I'm Chris Urwin. I'm the VP of Field Engineering for Rancher Labs. I've been at Rancher for over 4 years now and been in the container space pretty much since it started. Rancher, for those of you who aren't aware, is an open source management product for Kubernetes. And what I want to talk about today is it's not really Rancher specific. It's one of the challenges that we see around organizations moving from what I class as legacy infrastructure. So the typical place having 2 data centers and wanting to move more towards running applications in a sort of a more agile way, and allowing them to take advantage of the flexibility that Kubernetes brings. So I couldn't start a tale without some history. So really what this is, it's about the history of the infrastructure. So at the end of the day, people aren't really interested in infrastructure. What they're interested in is actually being able to run their applications, because it's applications that actually are what people want. They want to hit a website, or it's a financial application. They want to see their bank details. So in the 1950s, mainframes were the standard unit of compute, and they were huge and filled large rooms, took a huge amount of electricity and space, and were sort of programmed via punch cards, quite difficult to program for, and it took a long time to get anything done. Sort of things moved forward between there and the 90s. So obviously, Linux, Unix came along, and x86 came along and saw a resurgence. But really, it was around the early 90s that server rooms, as we know today, really, rather than mainframe rooms, became more popular. So organizations were starting to create rooms that were dedicated to running these servers with the power and cooling and everything else. And it sort of, after the initial sort of start of people wanting to run applications to provide applications for their business or externally, business to business applications, what they were typically doing was they were creating disaster recovery sites. So you would end up with 2 sites. In the early 90s, the vast majority of these were definitely in an active passive mode. So you had your active server room, and in the event of an emergency or a disaster, everything would be moved over. Now, there was usually involved unplugging some switches and plugging in some cables into some new switches, and so the move was pretty manual in order to redirect traffic. And I remember one of the organizations that I worked with in the early 90s, they created their first server room in the main building where everyone else was, and then they created their second server room in a building that they built specifically. It just looked like a big shed at the end of the car park, and it was built this way specifically because the span between the server rooms was wider than the wingspan, or just wider than the wingspan of a Boeing 747, which was the largest commercial plane at that time. Now, what they didn't take into account was it would depend on which direction the plane was coming from. So whilst if it was coming between the two, yes, it would have gone straight through the 2 data centers. But actually, if it had gone through a 90-degree turn, then actually it would have taken out both data centers in one go. So not really the best sorts of planning. But I think the majority of organizations typically had a few kilometers between their data centers, and sort of it allowed for them to have some form of resiliency in the event of a disaster. So come the mid-90s, there was sort of the dot-com era, large data centers sprang up everywhere. So this was sort of the instantiation of cloud. So your traditional organizations that were running, I don't know, your financial institutions and everything else, they typically had their own data centers, whereas in the 90s, the mid-90s, what you got was more colo type data centers where you had shared space, shared infrastructure, and it's sort of the next iteration of that came obviously when ESX came along and virtualization arrived, and sort of instead of having to manage 50 machines, you now had to manage 2,000 machines, but running on 50 bits of hardware. So you had the same number of physical servers and then more operating systems to manage. But fundamentally, the way that things worked didn't really change. The way that applications were installed in these servers, it didn't really change the way in which things were sort of managed or deployed. And then Kubernetes came along in 2014. And what Kubernetes has done is it's really revolutionized the way in which we deliver applications out to end users for consumption. So like I say, with virtualization, you just had more servers, and they were still operated and managed in the same way. You still had to install software, you still had to patch those operating systems, and you still sort of had your standard tooling for logging and everything else. When Kubernetes came along, it sort of turned everything a little bit on its head. It was more tied into sort of agile and sort of the change in development methodologies, where you move from developing in a waterfall methodology to sort of having more iterations with smaller code changes and getting things out faster. And this is what sort of Kubernetes really supported. It supported that fast turnaround and fast upgrade of applications to allow you to really move your applications forward quickly. So the other thing that it did was it changed the way in which infrastructure was managed. So there's a whole sort of the whole cloud native thing grows around this, in that you don't manage containers in the same way that you manage virtual machines. You don't monitor containers in the same way that you monitor virtual machines. So really, it sort of turned everything on its head, and it became sort of a challenge for organizations to adopt Kubernetes. In the initial guises, it was quite difficult to install, and that's thankfully got a lot simpler. But the challenge didn't go away in terms of the monitoring and the other operational aspects of that. So I'm not really going to touch on those within this presentation, because this is more aimed around the application delivery across 2 data centers, but it's just worth knowing. So the magic number. Back in 1989, De La Soul released an album, 3 Feet High and Rising, and one of the star hits off that was the magic number. And they said that the magic number was 3. 3 isn't a good number when you've only got 2. So 3 in the Kubernetes world is sort of the magic number, because 3 is what is required for etcd to maintain Quorum. So when you've only got 2 data centers, what do? Where does your Quorum go? So you can stick one of your etcds in one data center, you can stick another etcd in another data center, but what about the third? Now, there's obviously the option that you could say, okay, well, my third one's going to go in the cloud, but some organizations aren't quite there yet. They're still stuck with 2 data centers. So moving into the cloud isn't really an option. So there's a couple of sort of challenges around this, in that if you lose your sort of Quorum with etcd, then your Kubernetes goes into read-only mode, and you can start to experience a little bit of pain in terms of trying to do things with your infrastructure. So what are your options? Okay, so I can put 2 in one site and 1 in the other, which is fine. That will work perfectly happily until you lose data center 1, in which case you've still lost Quorum. So what are you going to do? You need to have some way of recovering this back, or some sort of backup failover type scenario. You're into a DR type scenario where you're going to have to restore your Kubernetes cluster into DC2. Similarly, you could put everything in 1. So it sort of gives you resiliency, in that if you lose data center 2, at least you don't lose Quorum, and your applications will continue to work. But again, if you lose data center 1, then you sort of have a bit of a problem, because you've now lost the whole of your Kubernetes, and it becomes even more difficult to restore from. So the solution that most places have ended up with when they're running 2 data centers is they end up with a Kubernetes installation per site. So each of those Kubernetes installations will consist of having your etcd, which is your data store. It will have your control plane, or a number of boxes dedicated to control plane, and then it will have a bunch of worker nodes. So with this scenario, what you have to do is you deploy your applications, and it depends on how you want to operate your Kubernetes, but this typically is operated more in an active passive type scenario, where data center 1 would become your active data center, and data center 2 would become your passive one. And only in the event where you had an issue with data center 1 would you actually fail over to data center 2. So what about the traffic? So the traffic, typically these data centers are going to be connected to a pipe that is bringing in traffic from the internet. So I'm assuming in these instances that these are data centers that are hosting consumer-facing applications, so web applications. But actually, it could be that they're actually running your own internal applications, so are consumed by your users internally and hosting your control systems or your financial systems. So typically you will have a pipe that comes in that'll split out at some point. Some of them will route through one data center to the other. Some of them will have an external pipe that will allow you to split your traffic and balance it between data center 1 and 2. And again, this is depending on how your network is set up and how the switching is set up, will determine what you can do with your data centers in terms of active and passive failover. So there's a couple of challenges with this model, and it comes down to sort of the way that you manage the infrastructure and the Kubernetes that underlies them and the applications that sit on top of them. So one of the things that we're actually seeing nowadays is we're actually seeing more of a clusters as cattle type approach. So instead of having a big, ginormous Kubernetes cluster that runs your application, what people are tending to do is they're tending to create more smaller Kubernetes clusters. So each one of these will have its own dedicated etcd, each one will have its own dedicated control plane, and each one will have its own dedicated worker nodes. Now, in some ways, it could be argued that this is maybe a little bit less efficient. In some cases, it will be, but it does give you that additional resiliency. So again, when I go back to the sort of the slide where you've just got 2 Kubernetes clusters, one in each data center, you start having to think about how you lay out your Kubernetes clusters within your data center. So you could end up with the same sort of problem in that if you've only got 2 servers in your data center at each site, you have the same problem with Kubernetes in that etcd requires 3 for Quorum. So how can you split it so that you've got your etcd Quorum that isn't affected by the loss of the majority of etcd Quorum by the loss of a single node? So whether it's data centers or servers, they can be sort of switched between the two here. But with virtual machines and virtualization, you could always run 2 etcds on one set of infrastructure, one box, and then the other on the other. But you end up with the same problem that if you lose the box that's running 2, you've lost Quorum and your Kubernetes is a little bit more broken. So the clusters as cattle sort of concept, what that allows you to do is it allows you to run your clusters in a way that you basically don't care about a cluster. So you can lose a single cluster, but if your application is running in more than one of those clusters, then you don't actually lose any of the sort of benefits that you gain from Kubernetes, in that you'll still be able to do horizontal pod auto scaling within your infrastructure boundaries. So you've got a little bit more resiliency. But one of the things that Rancher saw was we saw an opportunity here, and going back 4 years, pretty much all of the Kubernetes clusters that we were dealing with were all hosted in the cloud. So you don't have most of these problems. If you look at the major cloud providers, typically they are spread across multiple availability zones. So what that allows for is you can span your Kubernetes across those availability zones, and it's essentially the cloud provider's problem to take care of ensuring that those availability zones stay up. And typically they may lose 1, but you're unlikely to lose 2 of your availability zones. So it became a little bit more resilient, and I think it gave a lot more benefits in people doing that. The problem is, you fast forward that a couple of years, and a lot of the organizations that we're talking to now are coming from this traditional model where they've got 2 data centers. For whatever reason, they can't move into the cloud yet, be it data compliance or the organization's just not built for it and isn't ready for it. So they're coming to us with 2 data centers and wanting to know how we can help them solve their problems. So one of the things that Rancher does is it controls Kubernetes clusters, and it can spawn Kubernetes clusters very easily and sort of simply for you to, from a few commands, you can have a Kubernetes cluster up and running that is basically waiting for your application to come out and be installed on it. One of the things that we noticed with the way that people were managing their 2 data centers independently was they then had to make sure that they kept their applications sort of paired up across the 2 data centers. So they had to ensure that they had processes in place that would mean that they had the same version of applications in both sides of the site. Otherwise, when they did a failover, you may end up with data discrepancies, and the database may be at the wrong version for the version of the application that's running within the data center. A whole bunch of problems that can be caused by having differences in versions. So Rancher actually created a utility or a function within its operations called multi-class cluster app. And what multi-cluster app allows you to do is it allows you to take your Kubernetes application as a single object, but then we effectively manage it as a single object in Rancher. But when it comes to deploying it down to the Kubernetes clusters, we effectively deploy it as two separate applications. Now, you manage it as a single application through the Rancher interface, and then the work is on us and the underlying Kubernetes of those clusters to actually ensure that your application is deployed with the same version across those two. So it took away the pain of having to make sure that your Kubernetes and applications versions were in sync, because we took over that pain and we gave you the ability to just manage it as an application. All you care about is running your application, and you let us worry about running that application and the versions of that across the data centers. Now, there's a few assumptions that I'm making about applications here, and I'm going to discuss those in a few slides' time. So just bear with me on that one. Now, one of the other things that you can do there is obviously you can stick a load balancer in front of your two clusters, so the two red clusters here, and ensure that the traffic that is going through these is sort of round robin or active passive between these two data centers and these two Kubernetes clusters. But it doesn't just stop at one cluster. Rancher can give you another application and you can span that across 4 clusters. We don't care how many clusters you span it across. With multi-cluster app, you can span this across a number of clusters, and we take care of making sure that just the application version is the same across these clusters. So the underlying Kubernetes version could be different across these clusters, but the actual application version that you deploy, that your users hit, is always going to be the same and managed that way. So one of the advantages that sort of moving to Kubernetes gives you is that in the future, you aren't going to be tied to just 2 data centers. The likelihood is that you're going to want to move to the cloud. So with this and with Rancher and other tools that are out there, what you can do is you can easily take your Kubernetes clusters and effectively migrate those Kubernetes clusters and re-provision the workloads into a cloud-based scenario. So you take away the worry of having to think about how you're going to manage your etcd, because you can move into the cloud. And again, it's up to you how you manage this. You could move into the cloud and go with one big Kubernetes cluster, or you could actually go into the cloud and move into the clusters as cattle type scenario. So one of the advantages of staying with the clusters as cattle is that if we take, for example, a cloud provider that has 3 availability zones. So what you do is you spread your Kubernetes cluster across those 3 availability zones, and you have an etcd instance that's running in each one of those. Now, if you lose one of those availability zones, Kubernetes is all happy. It will reschedule your applications across the nodes that are spanning the remaining availability zones, and everything will continue to work as it was. If you then lose a second one, then Kubernetes goes into read-only mode. And it may be that parts of your application were only available in availability zone 1, and then that migrated to availability zone 2 when you lost availability zone 2. Then it can't migrate because Kubernetes doesn't know how to migrate it, and it's gone into read-only mode. So you end up with a problem of rescheduling. Now, if you move the clusters as cattle concept into the cloud and basically treat each availability zone in the cloud as its own Kubernetes cluster, then if you lose availability zone 1, then you've lost a cluster. You've still got 2 fully functional clusters. If you lose availability zone 2, again, you've still got a fully functional Kubernetes cluster. So what you can do is you can put automation in place that will allow you to sort of expand and contract your Kubernetes clusters, safe in the knowledge that actually losing multiple availability zones or regions will still allow your application to scale. And you can sort of bring that back into the data center space, and again, have automation in place that will allow your Kubernetes clusters to scale or automatically rebuild or automatically shift workloads and reprovision them to other working Kubernetes clusters. So there's a lot of flexibility that Kubernetes brings with it. However, there are still common challenges between legacy infrastructure and running your applications in the Kubernetes space. So The first one, and the sort of probably the glaring one that you were thinking, well, how can you do that if your applications rely on some sort of persistent data? Absolutely. We can't take away the pain of replicating data. So if your applications have a dependency on some form of externalized data store, whether it be a database or a file share, then you absolutely still need to sort of take care of this using legacy methods. If these things aren't hosted in Kubernetes, then you absolutely still have this problem. And again, moving to the cloud, you have exactly the same problem. So thought needs to go into how you're going to maintain your data replication. And the vast majority of organizations that I've worked with that have sort of come in with the 2DC problem, typically they've left the persistent data store outside of Kubernetes. So whether it be replication at a SAN level or replication at a VM level, the data consistency and resiliency between the two sites is taken care of in exactly the same way. So what they're running within their Kubernetes clusters is applications that are sort of not necessarily stateless, but stateless to an extent in that they can either rehydrate themselves from an external data store that's been replicated, or that it's just session data that's lost, and it's one of those things that it will recreate on the next event. So data replication is definitely one of the things that needs to be considered when you're moving, even when you're moving into Kubernetes space. So you still need to have this piece in place. Balancing of services between sites. And again, this sort of comes down to the data replication and consistency and effectively the consumption of data. So if you've got a primary data store that all of your applications are running, if your applications are running in an active-active scenario between two sites, then what you're going to end up with is effectively probably a DNS record that points at your primary data store, and both sites will consume from that. In the event of a disaster, there are processes in place that will fail over that DNS name and point it at the backup copy of your data, and then all of the applications that consume that will just pick up and carry on talking to the new backend. So when it comes to the balancing of services between sites, then you need to ensure that you have that in place, and you've got sort of the DNS and the routing all in place, and failover of those services if it's not active, to ensure that all of the traffic is directed to the correct place. One of the challenges where if you do have or you do decide to go down the route of actually spanning a Kubernetes cluster across two sites is again around the way that services are consumed and calls are made within Kubernetes applications. So if you have an application that is latency sensitive, then you need to be careful how that application is deployed across those sites because of the way that Kubernetes does its calls between services within the cluster. So the sharing of session state. So this is typically where a user has some sort of session state. So they've established a connection and the state is stored. Now, one of the common ways of storing this typically is in the virtual memory or the memory of the container that it's running. But you can back this session state out, depending on how hard it is to rebuild, to something like a Kafka queue that can be replicated and then retrieved. So again, you still have the same problems that you would have if you'd installed the applications natively onto those servers, and that you can't share the session state between those applications easily. So again, it's something that you need to sort of try and solve with the typical methods that you would use to solve it at the moment. So some of the things to consider when you're sort of looking at sort of Kubernetes and moving your applications and migrating between data centers. So one of the biggest things that you have to think about is the application architecture. So I've already mentioned that the persistent data store can sit outside of Kubernetes, and you need to be able to make calls from your web applications out to this backend data store. You need to ensure that that data store is highly available, otherwise your application is not going to work. So what you can do with this is you can use the legacy methods, or you can start looking at persistent storage within Kubernetes. So there are a number of storage solutions. I'll talk about them in a couple of minutes that can be used. but it's all around ensuring that your application has access to the data. The other thing, and I touched on it briefly on the last slide, is around the latency and the way that you design your applications. So if you have Kubernetes clusters that span multiple geographic locations, one of the things that can happen, unless you want to really constrain the orchestrator, is that when you have service A calling service B, it will call out to the Kubernetes service discovery, and it will say, I want to talk to service B. Now, service B may be running in the local data center. It may be running in all of the data centers. But what you don't have is the control of which of those containers that are running service B your call is going to get directed to. So what you can end up with is if you've got multi-layers of microservices making calls, you can actually end up with your traffic ping-ponging between data centers. So this is fine for applications that don't have a dependency on latency, but some applications are very latency sensitive. So those 10 pings may actually increase your round trip by, say, 100 milliseconds, which may be more than what your tolerance is for your application. It may time out for the calls, or it may be that the transactions that you're actually running are actually time sensitive. So the two examples sort of latency sensitive are things like share dealing. So obviously milliseconds can actually make a difference in the buy and sell price of a transaction. So you want the lowest latency possible. And also in gambling, where sort of odds are changing constantly, again, it can cost additional money for an organization if the latency is high and the odds change in the time that the user comes in and initiates the call to them actually getting out. So just bear in mind when you're creating your applications that the architecture that you want to put in place. And again, the clusters as cattle is a common way of solving this application latency issue, because there you can guarantee that if you run your cluster all in the same chassis or all in the same availability zone, you're not going to increase your latency by effectively physics from going from one data center to another data center. The next thing to consider is a Kubernetes management product. Now, obviously, I work for Rancher, so I'm going to say Rancher's the best management product out there for Kubernetes. But there are multiple Kubernetes management products out there. All of them will ease your pain in managing Kubernetes. Kubernetes isn't quite the beast that it used to be. It is sort of a little bit more tameable now, and there's lots of things that you can do to make it easier to manage and run with. But certainly bringing in the Kubernetes management product like Rancher, which can take care of sort of centralizing the authentication, centralizing security policies, ensuring compliance with policies. These are all big things that security teams, when you're going with your new architecture for your applications, are going to be very interested in. It also has sort of some of the day two operations. It has integrated sort of alerting and monitoring and service mesh. All of these things are available out of the box and fully supported within the Rancher product. So, like I say, taking one of these will ease your pain and adoption and allow you to sort of be up and running more successfully and faster with Kubernetes. So try and bring in people who know this space and can help you sort of take advantage of that. And we obviously have partners that we can put you in touch with who can make you work more quickly and efficiently with Kubernetes. Automation. Automation is key. Infrastructure as code is sort of key to making Kubernetes work well, whether it be in 2 data centers or in the cloud. Consistency and automation are sort of what you need. Long gone are the days, hopefully, in your organizations where you're running a single instance of an application on a server that was handcrafted by someone who left the organization 3 years ago. You've got minimal documentation. So actually, if that server goes down and it's a critical server, all hell breaks loose. So automation should be utilized heavily. And with Kubernetes, there should never be any surprises. You should always be able to recover quickly. There should be automation processes in place that allow you to recover in a sort of efficient, sort of consistent way between your various environments. And the last one I'm going to talk about is persistent data. So I've already mentioned it. So persistent data in sort of your traditional applications sits outside of the application layer and is just consumed by those services. But there are Kubernetes native storage solutions coming along. So databases are now running in Kubernetes, and file systems and file services like NFS and stuff are running within Kubernetes systems. So you can take advantage of some of the cloud native applications for providing resiliency of data. So again, Rancher has a product called Longhorn that we just GA'd this week that will allow you to replicate your data in an efficient way between data centers and sort of, again, allow you to recover more seamlessly. But there are other products on the market that I recommend you have a look at as well. So things like Portworx and Storage OS and Rook and Ceph are all solutions out there that can help you sort of provision persistent data stores within your sort of Kubernetes landscape. So I'm running low on time here, so I'm just going to pop to questions. I hope that was of interest. I hope it answered a few questions and sort of highlighted a few of the areas that you can sort of think about when you're looking at moving to Kubernetes and the challenges that you may face when you hit 2 data centers. This is something that obviously in the space we've got a good amount of experience with, and I'm more than happy to help. But if anyone's got any specific questions, I'm more than happy to answer any questions now.
Thank you very much, Chris. I hope someone has questions. Estonians are quite shy, actually, so if you give us some time, we warm up.
Yeah, that's fine.
Ühesõnaga, kui keegi küsida tahab, siis ma ei suuda seda ise lugeda sealt nii kaugelt. Can you also see the chat room?
Other questions. Conversations. Yes, I can. It seems like a very long list. I can't. So I asked via chat. Is it so that Rancher's main advantage is the ability to stay in read-write mode where there is only one availability zone left? That's not really necessarily a Rancher thing. That's more Kubernetes. So what Rancher allows you to do is it allows you to more easily manage multiple clusters. So if you're running with the Kubernetes as clusters as cattle sort of concept, then what it allows you to do is it will allow you to then basically continue working with that single instance. So the way that you do that is because it has its own dedicated etcd. So if you lose, you don't necessarily lose majority, because if you've only got one etcd and one control plane in a cluster, then you don't really care about the cluster as much. The cluster almost becomes throwaway. Your application is the important thing. So what you can do is you can spread your application across multiple clusters, knowing that actually you can suffer failure in every single cluster bar one, and your application will always be up and working. Whereas with a traditional Kubernetes deployment that goes across multiple availability zones, as soon as you've lost quorum within your Kubernetes cluster, you're sort of skating on thin ice as to whether or not your application is going to stay resilient or not.
Okay, I have one question from our side also. So,
yeah, Martin.
Hello, Chris.
I love your picture.
Can you listen me? Is my microphone on? Yeah, I hope so. Is. I have one question. Rancher has also one product called Submarine. What do you think might Submarine make also easier to manage 2 DCs?
So, yes and no. As is the question with most IT, the answer with most IT questions. So what Submariner will allow you to do is effectively create an overlay network between 2 Kubernetes clusters. What this allows you to do then is basically it allows you to consume applications in one cluster that isn't available in another cluster. So it doesn't really necessarily help with the 2DC issue if your application's only running in one of those clusters and it's only aware in those clusters. So it does have service discovery. So it could allow you some level of additional resilience in manage those. But you've got the same problem in that you would still have to run all of your applications in both clusters to ensure resiliency. So it just allows for traffic to be sort of overlaid between the two. The main, the reason Chris Kim, who was in my team at Rancher, he's now moved to our engineering team. The reason behind Submariner was people wanted a way of being able to back up their persistent data. So the original thing for this was someone had two clusters. They had a primary data store that was a database. And what they wanted to do was they wanted to ensure that they could back up that database to a second cluster in the event that in DR they could fail over and still had a copy of the data.
Okay, because we are running out of time, but I take the last question.
I'm okay if people are okay to stay. I've got no meetings after this. So
last question from the chat room is from Ilya. He's asking, is Longhorn envisioned to be used across DCs?
Yeah, so at the moment, so with the 1.0GA, I believe that the replication for the volumes is currently within a cluster. In a future release that will hopefully come out later on this year, it's definitely envisaged that you will be able to effectively take copies of your Longhorn volumes and have them in other clusters live. So we've got a Longhorn event next week that people should go to if they want to ask any detailed Longhorn questions. But what you can do as of now is you can basically back up your Longhorn volumes and do a restore into a second cluster. But I believe the roadmap for Longhorn will give us the ability to be able to effectively create live copies of those volumes into a second cluster. So your DR and failover would actually be almost instantaneous.
Okay, thank you.